Hello friends, so today we are solving this problem minimum time difference. So basically let's read the question first. So given a list of 24-hour clock time points in HHMM. So HH is hour and MM is the minute format. So return the minimum minute difference between any 2 points in the list. Okay, so we are given a array or list like this and we have to find the minimum difference between anywhere. So one simple approach is we could go to every pair using 2 for loop and then find the minimum difference, but that would be n square, right? That should not be our thing. So how to do that? First of all, these values are in string, right? So we have to convert these string format into the minute format. Okay, so how we will do is, first of all we will get the first part of it, like here this is, for example, this is 23. So we will get this 23 substring. So we can use just substring operation and we can get this 23, and we would multiply this with 60, right? So we got the minutes from the R part of it. Now we have, these are the directly minutes. So if we get the second substring of the size 2, this will give us directly 59. So we can use some integer.parseInt in Java, or maybe some other language also we have the conversion utility, right? So we will sum up these two and then we will get the total number of minutes. Okay, so this is our first task, that convert this all the values to the integral value in terms of number of minutes. Now next thing is, like, after conversion of this, how do we find the minimum difference? So to get the minimum difference, if we sort that array, the minimum difference would be always there between any two adjacent values, right? For example, let's say this is our sorted array, right? So in case of sorted, the value which would be the minimum difference would be always there in the adjacent value. For example, here 10 20, this is a difference of 10. Here the difference is 7. See, here difference is further bigger. But if we take these two guys, this is 1810 and 1811, the difference is 1 only. Okay, and similarly this would higher difference if we take this guy as well. So here we found, so the minimum difference would be always in a sorted array would come from any two adjacent values. Okay, so with this intuition we will try to find the values, okay, the minimum difference. So what we will do, first of all, we will convert our array into the minutes. So let's take one example. So suppose this is our array. Okay, now what we will do is we will first convert all of them into the minute format. So for example, if we are taking this one, so this is our this part. So we can take the substring of length first, 2 length. Okay, so we will get 23, right? We can just parse it into the integer value, right? So we will do in 23 into 60, because an hour has the 60 minutes, right? And this part, second part, means the last string of the length 2. This also can be passed into the integer. So this would we can directly add, because this is already in form of minutes. So see, here in this way we will convert to all of them, right? So we will put those values here. So guys, after conversion this into the minutes, we will get these values, okay, for all the cells, right? Now we have all the minutes here. Now if we want to make the efficiently adjacent minimum value, so to get the minimum difference, if we sort an array, okay, if we sort an array, then only we can get the minimum difference between any two adjacent cells, right? Because if we don't sort it, then we might have to use 2 for loop to get the minimum pair difference, right? So this will take O of n square time complexity, right? So to better it better, we should sort this array, and once we will sort, we will look for all the adjacent pair, because the minimum value will come always from the adjacent pairs in sorted array. So after sorting it, we will use that one for loop and we will find our this minimum difference. But wait a minute, there is one more scenarios. So see here, this is our sorted array, right? So we will go to all adjacent value. This is one adjacent pair. This is 1170 difference, which is huge difference. Then we will take these two guys. So again, this is like somewhere we will make a difference. What would be the difference here? So see, when we came here for this pair, we got the difference equal to 1170. When we came to this pair, we got the difference equal to 201. But when we are coming to this pair, we are getting 20 as the difference, right? So anyway, this is a happy path, and the answer would be 20. So far everything is clear, right? We will come to further more scenarios, and also this is, we are taking n log n time, right? We are taking n log n time. So can we do further better? We want to do in O of n. So we will come to that point, but let's first of all, let's clarify one more scenario with the input. So guys, same input, I'm just making a first value difference. Okay, I'm making this as 2348. Okay, so after I make this 2348, I will update all these values. Okay, so we will see what would be that case scenario. So see here, I just added this value, modified 2348, and I made this as 10. Okay, so this is one scenario of the input. Now we are converting, here I have converted them into the minutes, right? After converting them minutes, this would be our sorted array. The final one is our sorted one, right? Now we will check about the differences. So see here, this is 10, this is 1170. So what would be the difference? Difference would be 1160, right? So first difference we found 1160. Okay, now what is the next pair? Next adjacent pair? Next adjacent pair is the this one, right? So what is the difference? Difference is this is 1170, this is 1371, so it is 201 difference. So this time we will got a minimum difference better than the previous one. So far 201 is minimum. Now come to further. So we have this more pair, right? So if 1428 minus 1371, so this will give us 57. So the minimum difference would be 57. This looks like our answer, but wait a minute. This is technically we are getting 57, but see here, we are looking for the clock format, right? So in the clock there could be a scenario. Let me draw a diagram for better understanding. So I'm removing these things so that I can draw my diagram. Okay, so as you guys know, this is our watch. Okay, let's say this is our watch. Okay, so this would be the 0 place. Okay, now from 0, if we go to minutes way, it would go like this, and there would be the last value would be 2359, right, like this. So similarly, if we take this example here, we are starting at 10, right? So this would be, let's say, somewhere here. This is our start point at 10. Now we will traversing through, we will going through it. There is one place, it would be 2251, right? Similarly, we will going to this 1930. This might be somewhere here like this, 1930. And similarly, then we would be going to in this way. We are coming this way. Let's say this is our 2348. This point, suppose this is our last point. So now look at the difference. So far we found what was the difference. Our difference was 57, right? So this was the difference which we got from the array in this range. So let me draw a line. So we started from here, we are going until here we ended, right? So we got this 57 in this range, but we have this also a range, right? This is the last point here, right? And this is the our start point here. So there would be a difference, this also a difference here, right? So we have to take care of this difference as well. So see, we started at 0010 and we are moving through the clock, right? And this is our 1930, this is 2051, and this is our end point, right? So we are ending at here, we are starting at here. We got this 57 difference when we are inside this. Now we have to find also the difference of this difference and this guy, right? So we have to find this value starting and this highlighted value. So what would be this value? So as we know, we have 24 hours, right? So 24 into 60, whatever that would be, that many minutes we have, right, in a clock. So what we can do here is we can do 24 into 60. Okay, this would be our total time minus whatever we have till here end, right? We started at 10, right? We started at 0010 and ended at 23 into 48. So if we remove 24 into 48, basically the last size in a sorted array, last value. Okay, so if we deduct this value 23.48, okay, so this will give us this highlighted difference, right? This will give the difference till here, right, from 0 to this, because we started from 24 into 60 minus this value. Now we have this value also left, right? So this value, how much it is? This value is 0010. So we can directly add this 10. Okay, 00.10. This would be our, basically this also we have to include in our difference. So from the array we got 57, and from here how much we will get? So see here, I'm converting them into minutes, and this would be giving me the answer as 22, right? So 22, now we got this value as 22 and we got here as 57. So what is the minimum? Minimum is whoever is the minimum. So here 22 would be the minimum. So this, our answer would be 22. So far we are clear that what we have to do. First of all, we have to convert the array into minutes. Then we have to sort it. After sorting, we have to get the adjacent minimum, like we got 57. Then we have to also use this format, that 24 into 60 minus the last value in the sorted array plus the first value in the sorted array. So this will give us another value, and then we have to get the minimum of this value and the one which we got with the adjacent values. So 22 and 57, minimum is 22. Okay, so this all what we have to do. Now one more question is, in the sorting time we are taking basically n log n, but we have to do this in the n. Okay, but anyway we need to sort it. So guys, you know about the counting sort. So counting sort is used when we have the, or doesn't matter what will be the size of the array, but if we know that range of the values is not very huge, in that case we can use the counting sort. So let's take some, throw some light on counting sort as well. Suppose we want to do the counting sort on this array, right? So first of all, counting sort time complexity is O of n. Okay, so that is why we are going, but we cannot always use, when we know that the values, for example this array, if we make sure that highest value would be 6 only. Okay, so whenever we have the highest values are not very huge, like in our case it would be highest value would be 2359. Okay, so 23 into 60 plus 59 in this case. So for example, taking this example, what we will do is, highest value is 6 here, right? So I will create a another array of size 6. Okay, so see here, this is our intermediate array. Let's say call it count. This is of size whatever the max value in the given array on which we are applying the counting sort. So initially you can consider the values are 0. Whenever we create an array, by default it is 0, right? So we will traverse through this array. So what is the value here? 3. So at 3 index we will go and we will increase the value by 1. So it will become 1. Now we are at here. So what is the value here? It is 2. So we will go to 2 index. We will increase it by 1. Now we will coming to here. What is the value here? It is 3. So we will go to index 3 and will increase by 1. So this will become now 1 plus 1. So it would become 2. Okay. Now we are coming at here. So build at index 6. So what is the value at 6? So 6. So basically one thing is, like we have to create it of size of this size plus 1. Okay, so you can consider there was one more value 6. So this would be of max size plus 1, this guy, because we have the 0 indexing. So here what is the value at 6? It is 0. So we will increase by 1. Now come here, this is 5. So what is the value at 5? This is 0. So we will increase by 1. Okay, rest of these guys here is still the value 0 only. Okay, so remember this count would be of whatever max size plus 1 size, because we have the indexing. So now we got this array, all the frequencies of all the indexes we have got. Now what we will do is, we will either use this array or we can create another array. So let's use this one only. So I'm removing whatever value already existing, because we are doing the modification using this count sorted array. Okay, count frequency array. Now see here, what we will do is, we would be traversing through this count array. Okay, so let's start. This is 0, right? So nothing would be there. This is 0, right? So nothing, that means this index was never came, this values never came, so we will proceed ahead. Here also this is empty, right? So we will proceed ahead. Here it is 1, right? So that means we got 1. So this is the frequency that 2 comes one time. So we will at very first location we will put here what? We will put here 2. Okay, now we will go here. So here see 3 came 2 times. So we will put 3 2 times here. 3 and 3. Now we will come to here at 4 location. This is 0. That means it wasn't repeated. So it was not available at all. So we will not do anything here. Now we will come to here. So 5 came one time. So we will put 5 here one time. Now similarly we will at last one 6 came one time. Frequency is 1, right? 6 came one time. So we will put 6 here. Now you guys can see this is a sorted array. Okay, and we took only O of n, right? So that is why counting sort is very important, but we should know that the maximum frequencies in the numbers should be smaller. We just cannot go if there are millions, if there are very huge integer value in this array, then we cannot do in this way. So in our case it would be 23 into 60 plus 59, right? So this is not a very huge number. So we can go ahead with the counting sort so that we can do it in O of n time. Okay, so this would be our approach. So first of all we will use the counting sort so let me go to directly my code because we explained everything. So as you can see here, this is my code. So here see I'm creating that count array, right, of 24 into 60 size, because this would be my maximum value. Okay, so my size was 23 into 60 plus 59, but you remember we will do the whatever max size of this array plus 1, right? So that is why plus 1, if we do, this would become directly here 24 into 60. Okay, so this is just my size. Now what I am doing, I am creating, because this is given in terms of string list, so I am creating one answer size. Okay, now see here what we are doing. I am traversing through the time points, and here I am taking the substring of size 2 for the first 2 characters. I will get the hours here. I am just doing parsing. Similarly for the last 2 characters I am doing parsing and getting the minutes. Now we are getting here what would be the minutes, r into 60 plus 1 plus min. So I am doing this plus plus like the way we were doing in the counting sort, right? Here we were traversing through it and we were increasing the frequencies here. So same thing I am doing here. I am increasing the frequencies. Now finally I would have everything in count, just like we had the every count here in this count variable, right? After doing this, what we are doing, so for every frequency we are putting that index, right, in the answer array. So answer k plus plus equal to I. How many times? Whatever number of times count I has the value. See here 3 came 2 times, right? So what we were doing, we put these 3 2 times here, right? So same way what I am doing here is, we are first taking the count, and whatever number of count are there, we are putting those value into our that index into our answer array, right? And we are decreasing this count I value. So finally what we will be having is, we will have all the values. Now see here, we are taking one variable min diff to find our values. Now see here what we are doing is, we are getting here the adjacent minimum, right? We just calculated 57 in our example. So we are calculating here adjacent minimum, and after calculating the adjacent minimum, we are getting that that difference between the last point and the with the 0, right? We created this thing. We are starting from 0 format, right? And this would be our start point and this would be our end value. So we have to get this difference as well, right? So to get this difference, what we were doing, we are taking 24 into 6 minus whatever there at the last location of sorted array plus answer 0, very first value, start value, right? So finally what we are doing, we are getting the minimum of min diff plus whatever 24 6 minus this guy, right? So whatever is the minimum, we are returning that only. So let me execute the code. I'm running the code. Yeah, it is working fine. Let me submit it. Yeah, it is accepted faster than 92% of the solutions. So thank you for watching the video. If you guys have any concern, please make a comment over there. Thank you.